So condensed formula will have all of your carbons attached to hydrogens and to other carbons. Don't forget that carbon makes 4 bonds, and it always has to be attached to 4 other elements. So in this case, if carbon is attached to carbon, it has 3 other bonds that he has to fill out with hydrogens. This carbon is attached to 1 carbon and another carbon, and it has to be attached to 2 carbons only. You can see it very well on this structure over here. As you can see, when carbons are attached to carbons, the rest of the bonds are going to be done with hydrogen. Okay, so pentane, 5 carbons, 12 hydrogens. Over here you can have 1, 2, 3, 4, 5. Same amount of carbons, same amount of hydrogens. If you will add them up, 6 plus 1, 2, 3, 6 is going to be same 12 carbons. It cannot have a different number of hydrogens and carbons. It's the same type of a compound, just different way of representing the formula. Same way for nonane. You have 9 carbons and you have 20 hydrogens. So over here I wrote to you 9 different carbons. Make sure that you write 3 hydrogens on each side because it doesn't have any carbons attached to it. Okay, so same way of writing condensed. If you would be asked to write a skeletal structure for pentane, this would be the structure for pentane as a structural one. Here's another example of how you can write pentane as a structural. And on the bottom, we have expanded structural formula. Let me just write over here, expanded structural formula. Okay, so let's go back to our problem. The question number 6 is asking you to name the following alkyl groups. Alkyl group is the hint here. Make sure you know what type of alkyl groups we have. So this one, each alkyl group will have a dash right next to it, meaning when you have a structure of some compound, organic compound, this part will be sticking out of the main chain. So when you have only 1 carbon, it's called methyl. Make sure you change the suffix to -il. And over here we have 3 carbons. So the parent name is prop. You see what I mean when I tell you you have to memorize it, because it's all the same for all of them. You're just changing the suffixes. And -il, alkyl, meaning that you're adding -il suffix. Propyl. This is the amount of carbons that will be side chain out of your parent chain. Okay, so let's go to the most interesting and sometimes the most difficult for students part. How do we name certain organic compounds? We'll start with very easy ones and then we'll move on to more complicated ones. As you go on with organic chemistry, you'll see that there are a lot of different organic compounds that might confuse you, but it's very helpful if you understand in the beginning how you start with the very simple ones, because then you can move on to a more difficult, and it all makes sense as long as you memorize the most important parts and then you just follow the rules. The pages that I posted for you for IUPAC naming will be very helpful for all of the different types of organic compounds. So let's start with a very easy one. So you're given a skeletal structure and you were asked to name this structure. So over here I already numbered all of the carbons over here. So how do you determine what are the carbons in a skeletal structure? So this is a carbon over here. Each angle over here, right, represents a carbon. On the sides, on the ends of the structure, those are the carbons as well. So for example, if you mark these areas with dots, you'll see that these are all carbons. And the skeletal structures, we do not show any hydrogens, but we assume that each carbon has enough of hydrogens to make 4 bonds. So this carbon would have 4 bonds. So any of them will have 4 bonds, but this carbon will have 3 hydrogens. This carbon will have 2 hydrogens because it's bonded to other 2 carbons, right? This carbon is bonded to other 2 carbons, so it will have only 2 hydrogens. Same for this carbon. And this carbon, carbon number 1, will be like carbon number 5. It is bonded already for 1 carbon, but it needs 3 more bonds, and therefore they will be filled with hydrogens. So how do we name this structure? I put numbers for you, but you can also, you don't need to number every single one of them. You can just have it, it's probably not going to be numbered for you. So you can number it to just make your life easier, to make sure you understand how many carbons are over there. So this structure has 5 carbons, and all of the bonds over here, as you can see, is represented with only one single bond. It's a single bond. There are no double bonds. So we know that this is alkane and it has 5 carbons. If it has 5 carbons and it's alkane, it is pentane. And this is very easy because you do not have any alkyl groups attached to it, so it's easy to identify it right away. Okay, let's look at the next one. So you will be given something like this, for example, right? Let's count all of our main parent carbons. So you need to find the longest chain over here. You can start with any carbon. So let's start this way. 1, 2, 3, 4, 5, 6. So we calculated 6 carbons in the longest chain, right? If we go this way, 1, 2, 3, 4, 5, 6. Again, 6 carbons. Let's try something different. 1, 2, 3, 4, 5. Only 5 carbons. This is not our longest chain, so we cannot assume that this is going to be the right naming. What if we'll start with this end? 1, 2, 3, 4. We can go this way, but only 4 carbons. It's not the longest one. Let's try another way. 1, 2, 3, 4, 5, 6, or 6 this way. But here's the trick. When you start to name it, you want all of your alkyl groups to be on the smallest numbers. If you start numbering from starting with this end, it will be 1, 2, 3, 4, 5. So you'll have 3 and 5. But if you'll number it this way, from left to right, you'll have 2 and 4. And this is more preferable way of naming the any alkane. So how do we start? First, you start with naming your alkyl groups. So you have only 1 carbon over here. This is not the carbon that you will be counting. It is part of the main chain, right? The parent chain. This is the only carbon you are counting. So only 1 bond. It is there are only single bonds around here, so it's alkane, we know. Very good. So there's only 1 carbon, so it has to be methyl. There are 2 methyl groups, but we do not name anything as 2 or 3. Remember, we changed them to Latin. 2 means di. So if you have 2 methyl, remember it's alkyl group, so the suffix changes to YL, not methane, but methyl. So dimethyl, and you make sure that you specify where exactly they are located. So it is located at carbon 2, comma, at carbon 4, and then you write dimethyl and the name of your parent chain, which is hexane. 6 carbons, all single bonds, so it's alkane. So the name of this compound is called is 2,4-dimethylhexane. Okay, so let's try to name some of the other things that are very common, and some of them you actually have to memorize because you will see them so often that it's easier to memorize to just look it up and try to figure it out. So example A is something cyclic, right? And it has 6 carbons. 1, 2, 3, 4, 5, 6. So you know if it's cyclic, you write cyclo as a prefix, right? Let's write it in a different way. And there's 6 of them, hexane. And they're all single bonds, right? We don't see anything else. So it's alkane, and you add ane. I write for each one of them. If it's something more complicated, I'll write the explanation, as you know already. So here is my explanation. This is something you need to memorize. The cyclohexane with the circle inside, or 3 double bonds inside, is called benzene. This is something you should memorize. This will be shown to you a lot. Example C are 2 carbons and they're attached to each other with a double bond, right? So double bond means it's alkene, and therefore we change our suffix to -ene. 2 carbons means it's ethane. Oops. Means it's ethane. What did I do? Ethene. And over here the suffix is ethene. Look at this. And we'll just underline the parent name, which is ethene, from ethane to ethene to ethine. Okay? Okay, so let's name all of these compounds. I looked it up online and I found a couple of very interesting ones, and I want you to feel comfortable naming some of them. Some of them are a little bit more complicated for you, but why not try? If you can name these compounds, you'll have no problems with naming anything else. So first of all, we have to find the parent chain. So what is the longest parent chain? So 1, 2, 3, 4. There's a certain way of naming the cyclic compounds. Whatever is cyclic is going to be either parent chain or some sort of alkyl group. So you are not making this chain longer. You cannot make it longer. So not 1, 2, 3, 4, 5, right? Or like 1, 2, 3, 4, 5, 6. It's impossible to do that. So when you have something cyclic, it goes separate from the main chain, or maybe if it's more carbons over here, then this is going to be the alkyl group that you'll make sure to add to the naming. So over here we have only 2 carbons, and over here we have full 4 carbons, right? 1, 2, 3, 4. So this chain is longer. This is 1 carbon, 2 carbon, 3 carbon, 4 carbon. And whatever is attached to the first carbon is going to be always carbon number 1, right? So this is not going to be carbon number 1, or this is not going to be carbon number 1. This is going to be your carbon number 1. So we have cyclobutane because there are 4 carbons, and then there are 2 carbons that attach to our cyclobutane. 2 carbons that are connected with a single bond. This is ethyl group. 2 carbons is called ethyl, right? And the rest of our main chain is called cyclobutane. You can definitely specify at what carbon it is located, right? Ethyl, cyclobutane. But since there are no other alkyl groups attached to it, we don't even have to add it. You can write just ethyl cyclobutane because there's only 1 group and it's always going to be attached to carbon number 1. Okay, let's move on to the next one.